Hi, welcome to the fourth lab in the Serverless ML course. In this lab, we're going to build serverless user interfaces, and we're going to use a couple of technologies, Gradio and Streamlit. These are Python-based frameworks for building user interfaces. And we're also going to build a more complex user interface for the credit card fraud detection project that we've been working on since the second module. So we're now in the fourth module. So let's get started. We're going to cover in this lab how to build a serverless UI in Gradio and deploy it on a serverless platform called Huggingface Spaces. Now we're going to use the example that we used in the first lab called Iris Flowers. So you'll be very familiar with that example, hopefully at this point. And it'll just be some small changes to the original code that we'll need to make to deploy our serverless UI on Huggingface Spaces in Gradio. Firstly, we're going to deploy it as a Python file, not as a notebook. We've been working with notebooks to date in the Iris example. And the second part, we're going to write a user interface for the credit card fraud batch inference pipeline that we completed in the previous module, module number 3. And we're going to base it this time on Streamlit. That's a different Python-based framework for developing user interfaces. It can also be hosted on Huggingface Spaces. We're going to just run from our Jupyter notebook, but running it on Huggingface Spaces is also supported for Streamlit applications. So that can be your homework for today. Heads up. All right, let's get started. The first thing to do is to pull any changes that we made in your fork of the Serverless ML course. So that's not here, that's this one here. So you can go git pull upstream main if you've called it, or whatever name you've called it. So you can call git remote -v to find the name. I'm actually on the main, so I don't have a remote. But if you've got a remote, you'll pull from that remote and you'll get the latest changes. I would also recommend you to do a pip install -u to upgrade Hopsworks, because we've actually done some small releases, small changes, fixes, improvements, no breaking changes, but please do upgrade your library. Okay, that's it. Let's go back. We've done that. So what's the next thing to do? Well, we're going to use Huggingface Spaces. And I mentioned there are a couple of serverless user interface platforms that are actually free to run with. Streamlit have their own cloud, Streamlit Cloud, which you can use as well. We're going to stick to one platform in this course, and we're going to stick with Huggingface Spaces. The reason for that is that it supports both Streamlit and Gradio applications. So Gradio is actually a framework that's developed by the Huggingface company. And currently, as of October 2022, you get 2 free CPUs and 16 gigabytes of memory on your Huggingface Spaces account, which is really great. And in Streamlit Cloud, what will happen is you will get a free CPU and you get a Docker container or some sort of container. But what it does is actually swaps it out. So if it's not been accessed for a little bit of time, it's very slow then to reboot your instance when you want to access it again. Huggingface Spaces, it seems to be running 24/7, which is great. So this is what it looks like. You can see here. There's a link to the URL here. I registered an account already. I'm not going to go through registering an account. I assume you're well capable of doing that. What I'll do is I'll just go and show you my Huggingface Space, and then we'll go and proceed to do the first part of this lab, which is we're going to rewrite the Iris user interface in Gradio. We had part of that from the first lab. We actually had the end-to-end ML pipeline. We had a UI in Gradio that we'd written for Iris, and we're going to use basically the same code, but this time we'll have to move it over to a Python file, and in fact it's going to be called app.py. So what we'll need to do first is create a Huggingface Spaces account, and then create a space for your Iris UI. I called mine Iris. Then you'll need to run the workflows from our first lab, the feature pipeline, the training pipeline. We won't need the batch inference pipeline. In this case, we're going to have an online UI for interactively querying the model. But you should run the other pipelines to make sure that the features are there, that the model is there. So what we're going to do after that is we're going to have to, once we've created the space, we'll have to check out the space into your account with Git. So let's have a quick look at that before we move on. We will have to add a couple of files. We'll have this app.py file and requirements.txt file we need to add to our space. And that's basically it. So I'm going to go ahead and do those things now. Let's have a look at the command line. It's not here. It's not here. This is the one. Okay, so this is my, we'll have a look in here. This is my Huggingface space. You can see it's normal Git. My username is J Dowling and the space name is Iris. We can probably get a link to that and then open it. Let's have a look here. This brings us here. So this is my user interface. Now this is the same one we had in the, I actually have it open a couple of places here. This is the same one we did in the first lab. The only difference now, in the first lab, we ran it in a Colab notebook. And when you run it in Colab notebook, you need to be somewhat technical to be able to run that Colab notebook. Now we did get, Gradio does give you a temporary user interface that you could give to somebody else, and they can access the user interface from your Colab notebook on Gradio over the web without having to run the Colab notebook, but it's only temporary. So if you're to write a Gradio program and you want to make it available as a serverless UI for a long period of time or indefinitely, then this Huggingface Spaces allows you to do that. You can basically have your Python program, which is going to, in this case, give us the nice Iris Flower UI, and it'll run 24/7. So, if I press submit here, you say it gives me an Iris Setosa, and we can play around with our numbers, and we should get either Virginica or Versicolor. Here we got Versicolor. I think if we go a little bit higher on this one, I'm becoming a bit of an expert at the lengths that we need here. Hopefully that gives Virginica. Nope. Maybe we need a 3 and a 2 there, is it? I don't remember. Come on. I'm not very good at this. Okay. Maybe it was a 4 and a 3. Go on. We'll make that a 7. Yes, we finally got a Virginica. So this is the same user interface we had before. But what we can see here in Huggingface Spaces is that we have, this is our app and this is the user interface, but we also have the files that I uploaded already. And you get a README out of the box. I didn't do anything there. Git attributes, I didn't do anything. I added this app.py file and the requirements.txt file. Now they're both currently in our GitHub repo. So if we open our GitHub repo, when you fork them, you'll get them. They're in module 4. So if we have a look in here, in source and 04 module, you can see here's your app.py file. And the requirements file is not called requirements.txt, it's called requirements-gradio, just that you know explicitly it's called that. So you'll have to rename it when you fork it. So what you'll need to do basically is the following. You'll go to your, this is our course here, and we have our files. So I have app.py, and then I have the requirements.gradio file. And then the other directory is in projects Iris. So you want to copy those files there. So you just copy your app.py. This is the GitHub repo for the Huggingface Spaces that I already cloned locally. And you'll copy that there. And then you rename the requirements.txt file to, so let's go there. It's actually, I think I got it checked out here. So we'll rename the requirements.txt file to be from requirements-gradio.txt to requirements.txt. All we need are Hopsworks library, joblib. We're going to download the model from Hopsworks, and then we're going to have scikit-learn. So let's have a quick look at the app. We can see it here. We'll probably see it better in the browser. Let's have a look in the browser. So we go in here. Okay, we can see here that we have Gradio, and we have NumPy and Pill, and you can see they're not in the requirements.txt file, and that's because Gradio comes with quite a lot of libraries built in. So Pill and NumPy and Gradio and requests are already built in. Hopsworks and joblib weren't built in. Now, do we have scikit-learn in here? I don't think we actually need scikit-learn, so you can probably remove that one. I think the scikit-learn one was when I was actually transforming. That was one of our homeworks, was to transform the input features and then to encode the label, and that's when I needed scikit-learn. I needed to download also the transformer object, but here I'm not doing that. So we can see in the code here it's the same as before. We're going to log into Hopsworks. That means we're going to need to set the API key in as an environment variable in Gradio. So in this case in Huggingface Spaces. We'll also need to download our model. And we're just going to download it locally, and then we're going to read that model from the local file system as a pickle Python object, and we're going to deserialize it into the Python object model that we can make our predict with. So this is model.predict down here. So just to remind you, in Gradio, you define this method, and the method here is this function in your Gradio interface. So it's iris is our function here, and this is it here. We can see there's 4 parameters. These are the 4 input features for the iris flower model: sepal length, sepal width, petal width. And we just call model predict on these inputs. So we turn them into a list, and then we cast our list to a NumPy array, reshape it, and then we get our result back. And the result will be the name of the flower. So what we're going to do is get back the URL for that flower name, so including the PNG, the image file. We can open that image file by downloading it and then returning the image. And that's the one we see on the page. So to launch the Gradio application, you need to specify your function. We put a title in here and a description. Those we can see here, the title and description. You'll see when we go back to the page here. This is our title, and this is our description. And we go back to our program again. And then we have this allow flagging. So another part of Gradio is there's a button called flag where you can flag if there's an issue. And I just disabled it for this example. And then finally you have demo.launch. And in the first example, we had some flags like debug equals true, and then whether you want to make it online or not. In this case, we shouldn't have any parameters when we're running it inside Spaces. Okay, and that's pretty much it. It's a pretty straightforward program. This is pretty straightforward and it's really nice. And it's using the model from that we've deployed in HopsWorks. So if we go to HopsWorks, we'll see our model here. And okay, I am logged in, which is good. Okay, let's go to HopsWorks. And in my model registry, I have this iris flower. So it's downloading this iris model object here. And if we want to see the actual model object here, you can see this is the accuracy of it. You can see the model file. So this is the actual file that's downloading, this one here. And you can actually download it from HopsWorks as well if you want to locally to have a look at it or try it out. But basically that's what's happening. It's the Gradio application will go here, download this, load the model, and then we interactively explore the model using the UI here. Now, that's it. Now, for Huggingface Spaces, you can create new spaces. So you can create a space, let's call it credit card fraud, for example. Credit card fraud. And pick a license. We're always open source, of course. So we pick Apache v2. And now you have a choice between Streamlit, Gradio, and Static. So I haven't done anything with Static yet, but I played around with Streamlit and Gradio. Always make them public, right? Because it's great to help people learn from one another and to show off your work. But also if you want to allow people to access the space, then it should be public. So what I recommend you to do is create one for the credit card fraud example, because that's your homework, right? We're going to upload our Streamlit app here, and then you'll have this showed as an application on your Huggingface space. I'm going to run it locally, just because I want to, but it doesn't make a difference. Now let's have a look. We have in here, this is the second part of our lab. So let's go back to the lab and see where we were. So we finished this. We've tried out a new UI in Huggingface Spaces. We played around with it. I didn't make any improvements, but you can go ahead and see what improvements you can make. And then we'll move on to the second part of the lab, which is that we're going to use the Streamlit UI for our credit card fraud batch inference pipeline. So to do this, you'll need to already completed labs 2 and 3. And you'll also need to run the credit card fraud pipeline from module 2. You'll need to run this one here, CC feature pipeline. And the reason you need to run this is because it's going to write some data to your feature group, and we'll see in the pipeline here that we're going to run this CC fraud stream. This is our one here, CC fraud Streamlit UI. What it's going to do is it's going to download some data. Now I put down 200 hours. So if you've written some data in the last 200 hours, that should be enough. But if you haven't written any features to your credit card pipeline in the last 200 hours, you'll need to run this one again. Okay, so let's go have a look at this. I'll just show you how to run before we go through while it's running. I'm going to go through the code for it. Now there is a script here. We can see it's called run-fraud streamlit.sh. it asks you to enter your API key, and it maybe asks you to enter your project name as well. The project name, in case you don't know, is up here. You can see I'm in okay, let's not go to course module 1. Let's go to FS.org. So you can see I've got more than one project. That's because one of the students in the project actually invited me into their project. So now I've got access to 2 projects. So you do need to specify the name of the project in case you have 2 projects. Now, probably most of you don't. You have 1, but if you just take the name here and enter it here, then it'll work fine for you. Otherwise, you can just set the API key, which I did already. And because I've set my API key already, I don't want to paste it in here that you can see my API key. I'm just going to run this command here, which is the one which runs Streamlit. So this command is, I've already pip installed Streamlit. So firstly, what I would need to do is you need to call pip install -or on the requirements.txt file. I've done this already. This one here. Because there's a couple of new libraries we added for this module. Let's have a quick look at them. So we added Plotly, Folium, Streamlit Folium, Folium twice. So that's a mistake. So let's fix that. I think we actually don't need Folium at all because we have Streamlit Folium here. And then we'll need Streamlit, of course, as well. But Streamlit Folium will give us Streamlit as well. So those 2 are the main ones. Okay, let's have a look at them again. So we have, Streamlit Folium and Plotly. Okay, so let's look at the script we need to run. It's going to call the Streamlit program, and it's going to, from Streamlit, it's going to run our UI. So when you run it, we did this already, if you remember, in the very first lab, we briefly wrote a Streamlit app when we ran it from our laptop. But you can see what's happening here is that, and I'll just close that. We can go back here and have a look. It's now saying, oh, I need to enter the name of my project. So this is number 1 is the project I want to use because I didn't export my project name. So you can see here it's connecting to Hopsworks now. And in this case, what it's going to do is it's going to first log into Hopsworks, and then it's going to actually download a big batch of data to score with. So it's going to download, I don't know, 100, however many credit card transactions have arrived in the last 200 hours. It's going to download that many, and then it's going to score those transactions with the model. It's also going to download the model, and then it's going to do that. So you can see what it's doing that now. It's running this complicated point-in-time join to download the credit card transactions that have arrived in the last 200 hours. I'll go through the code so that we can see what's happening here. You can see it says here it's connected, and now it's running trying to download the data, and it's going to try and score them. This is our user interface, in case you're curious. It's called fraud detection. It connected to the model registry. It's now downloading and running the data. Let's have a look at the code, and we'll talk through the code. So we have some imports at the beginning here. They're kind of mixed up. I don't know why they're mixed up across many. Oh, I do. This is a Python program. So this is not a notebook, and we're just reading it in a Python program, and that's why you can see there's many cells. So we have a lot of imports at the beginning. And what we do is we just get a start date and end date for the credit card transactions we'd like to score. And this start date is the current time. So the current time, in this case on my laptop, minus 200 hours. And the end date will be the current time. So we're going to take all the transactions that arrived in that period of time and score them. So let's see what we're doing. This is just getting us a list of credit card numbers. And let's have a look at the code. So what it does first is it logs us in, and we have some functions then. The functions are to retrieve the data set, and it uses the feature view to get all of the batch data in that 200-hour period of time from the start time to the end time. There were 3 features that are helper features: the transaction ID, the credit card number, and date time. They're not input features of the model, so we drop them. And we get back a batch of data. That's the batch of data we're going to score. The feature view itself, we can get a reference to it here. You can see this is CC trans fraud. We can see it if we go back to our project here. This is CC trans fraud. This is fraud. This is my feature view. And these are the features in here, you can see. So just these first 2 and credit card number, they're the ones that we won't be passing to the model, but the other ones will all be passed to the model. Let's go back. We have then getting the model. So we're going to download the model from the feature store. We saw that already. So I have that model here as well. You can see it here. It's CC fraud number 1. So the model is there. We have some score or performance for that model. And then we have, explore data. So this explore data is basically going to draw our visualization of the credit card transactions. And in this case, the only thing we're going to do is we're going to count the number of credit card transactions that we think are normal, and the model thinks are normal, and the number that the model suspects are fraudulent. And then we're going to do a pie chart. So it's going to use Plotly to draw a pie chart of that. These headers, we can get to make it look nice on the screen. That's this code here with some markdown. And we can transform the predictions into from numbers, because we get them out as numbers from the model, into strings, so that we can show them to the user in strings, which is easier for users to understand than 0 and 1. So if you say fraud or not fraud, or we could have suspected fraud, might be more accurate than just fraud here. Okay, so that's just pure Python code. We haven't seen anything really apart from these caching annotations here. And these caching annotations here are so Streamlit is quite reasonable performance. And you can add annotations here to tell it what to cache. So allow output mutations, yes. Suppress any warnings from this ST or Streamlit object. So this is ST here. Where do we have it? Streamlit as ST. And so if we go down and let's have a look at the actual Streamlit code now. So it starts off with a progress bar. So we're going to say working progress, and that's a sidebar. And then we have a title, fraud transactions detection. So if we go back here, we can see we've got fraud. This is our title. And then we've got this working progress bar on the left. And then we have, it prints out connecting to the feature store. Then it says connect to the model registry. It downloads a model. And then when it's succeeded in downloading the model, it'll write out connected. And we saw that back here. So this is here, and it writes out this connected. Okay. So it's kind of a linear application, which is easy to make it look like this. And we can see it's come all the way down to download the data set. And you need to click on make a prediction, I think, for actually to make a prediction. It's going to go through all of the credit card, all of the individual credit cards, and then score all of them. So it takes a little bit of time. But let's have a look there. So the next thing it does is it says it gets the feature view, and then it retrieves the data set. So we saw that at that point. This is the batch data we're going to score. So we've gotten this far. And then we update the progress to be 55%, which is this thing on the left. It goes a little bit further. We've retrieved it. Now, at the moment, it's currently scoring the transactions. So it's now currently at this point, it's running this. It's saying model.predict on all of the batch data. This is the data set that was returned, the batch data. And this takes a little bit of time. And then we turn them into transform predictions is this function we had up here, which is going to basically turn all the predictions from numbers 0 or 1 into strings, so that it's human interpretable. And then we make a copy of the batch data, we basically call then this explore data on the fraudulent examples, right? So this explore data function that we saw up here, this is the one that's going to draw out our pie chart. And what it's basically going to say is count the number of fraudulent values and return that, and then plot that in the pie chart. So let's go back and see. It's still going. So you can see it's a bit slow to. I think I may have maybe 100,000 or something. I can't remember exactly how many values to score, but you can see it takes quite a bit of time for that to run. So you can obviously help reduce the time by having less data that you download. So if we go back to module 2 and you have too much data that you're downloading, in this case it's the time taken is mostly just scoring the transactions, and probably you can optimize that and make it work in parallel. But in this case, you can see here when I'm running my feature pipeline, I say, well, how many rows to create? You can reduce the number of transactions in total that you're going to write, so that you've less data to score. Okay, there we can see that it's finally returned, and we can see that we have this pie chart showing the distribution of predicted fraud transactions. We can see that 128,958 of them are not suspected of fraud, while a small number, we can get this little red one here, 81 transactions are suspected of fraud. So that's it, and you can rerun it and wait a few minutes for it to complete again. That's it for this lab. We can go back and see that the homework is to run this Streamlit example as a Huggingface space. You can just create it as a Streamlit app and try and get that up and running on Huggingface Spaces. So that's it for today. In the next lecture and next lab, we'll cover ML ops. So we've gone from for the credit card project, the credit card fraud prediction project, we've gone from the beginning, the feature pipelines, the training pipelines, the batch inference pipelines, to now having the full user interface. And we'll look into how do we operate and run this type of project with some support for automated testing, versioning, upgrading, and so on. Thanks.